So both of them are starting to run around to look for compensation. And the crystals of ribosomes, where there is a lot of solution there, so they could run faster. And when they look for solutions, they break more bonds and more bonds and more bonds. So it's propagation of the initial problem. So the initial problem, I didn't think that I can fight, but I didn't really care. For the structure, it isn't really it's not important. Where is one electron here or there, because anyway, we look for the atom. But the propagation, it needs energy for them to run. And if we reduce the temperature, we reduce the energy, so there will not be propagation. It worked. It really worked. The same evening that we started, it took a year to prepare. And when we did the experiment, our collaborator that I show here, Hakon Hope, who is maybe, in my opinion, more crazy even than I was, or I am, he told the Stanford people, the Stanford staff, that it will take place. So they knew. I didn't tell them because I was skeptical. I wanted to see the result myself. But he told them ahead of time. And they were standing on balconies around the station. And when they saw us, 10 hours after we started at the early afternoon, by midnight we saw it, they kept looking at us. And when we started to jump, we made it, they announced it in the whole world. And while we were there, the whole world, people from everywhere called. It's the only experiment that during the experiment, I was approached by the scientific community. Really, it works. And when I said, at least one of them, when I said yes, he said, anybody more reliable to verify it? It means people really did not believe it. But what I want to show you, not only we now get good results, and I'm still happy, but the world. And this is the innovation. So if you look at this result, or this table, it talks about PDB, which is Protein Data Bank, the positions. So everybody that has a structure has to deposit the structure there, the coordinates there. So it's it shows how many structures were determined. Until 87, look, there were hardly any structures. This, the y-axis here should be multiplied by 1,000. So what you see is this times 1,000. In 87, we introduced the cryocrystallography. Same time in Columbia University in New York, they introduced a new way for phasing, which is very important too, and better detectors. Until then, we measured on paper, on film. All this happened, and I think that we contributed a lot, at least for measuring these two things. And look what happened. Look what is the result. For innovation, I think it's the biggest thing I did in my life. It became routine within 4 months. We left our freezing facilities in all synchrotrons because it was easier for us to produce one and take with us than to send back. It was made of glass at that time, and it was very fragile, and so we left everywhere. And people determine. It's much more than this. These structures here are of normal enzymes and normal proteins, but mainly of compounds that should be useful for proteins that should be useful for medicinal reasons, for medicinal development. And most of them are crystals that couldn't be used otherwise, small or fragile or whatever you want to call it. So I think that, well, it's many years ago, but we did it. I want to tell you that afterward, we wanted to put a machine like this also, a cooling machine also in our home crystallization lab, crystallographic lab. And we had a crystallographic generator that exactly at the same time we changed to a stronger one. And people from Rigaku, it's a Japanese company that makes these generators, came to see how we put the cooling on it. Now, our lab is about 500 meters from a train station, a train track. And because of it, the floor is floating, but we also put water cushions below the legs of the generator. You know what the Japanese did? They looked at the cooling, took some measurements. We modified their detectors distances, so they took some measurements, and then they asked, what is this cushions there? And we took, and they solved it right away, as if it's there. We didn't even think about protecting it in a patent, so now we are a little bit more clever. So this is my biggest innovation, and I'm happy to share it with you. So the Weizmann let me be the president at that time makes the decision based on advice from these very important people. We started it all in Berlin, and they helped us to have a lab of our own in the synchrotron in Hamburg. I had 2 research groups, and here I just want to show you because I'm very proud of them. The first in the Hamburg research group that always had angels. These are the technicians that had to cope with all these problems, that went to Israel, to the Dead Sea to look for better bacteria, but just had fun. I want to show you the Israeli group that is, the Hamburg group was terminated 6 years ago, that is run by Dr. Yonath Bashan, who is our scientist. And I only want to focus not on who paid and all this, just on Tamar, that came 13 years ago as a bachelor. Now she's a mother of 3. And she came for 10 weeks, 13 years ago. And in the day that I took this picture, she had a birthday, she made a cake, and this is her cake. So it shows that ribosomes are sweet in my group. I want to thank my family. Want to show you, you talked about prizes here? You did? That's the most important one. The grandma of the year is Ada Yonath. She didn't write a year because she told me that I have to reprove myself as grandmother every year. And she will take it off. And this is what happened to me. So this is the small subunit, and the large subunit, and an antibiotics here. So you gave me flowers, and I give you back. Thank you.
Yonath, for a very interesting talk. I confess that I didn't understand much because I don't have the background, but there was one truly philosophical statement in your presentation where right at the beginning you said that in nature, structure is function. And that, in my opinion, has implications far beyond the subject of your research. If we get the structure wrong, we get the function wrong, and I think this is the truth that enables us to understand, if we wish to, what is really wrong with the structure of our society, which is why it is not functioning well. So this, for me, is a very, very important takeaway from today's talk. Friends, we are very happy to have some time for a question-answer session. Please introduce yourselves and ask. Including, your dream, your passion, and your persistence.
Innovation.
Friends, that really, before we begin the question-answer session, we would like this question-answer session to benefit us, that is, benefit the Observer Research Foundation in knowing her ideas on fostering innovation, research in the academic institutions in India. So if we can have some discussion on that, it will be very useful for us.
Okay, maybe this can relate to that. My name is Kavi Arya. I am from IIT Bombay, a professor in computer science. Chemistry used to be a passion of mine at school. and partly because I find it easy to reason spatially, right? I've seen that a lot of the illustrations that you do are spatial. That means you're looking at structures and seeing the shapes and how things negotiate the way through them. Is that kind of reasoning used a lot by a chemist like yourself in understanding how the function of a structure works?
Yeah, this is exactly.
So how important are those 3D models, if you like, in trying to understand what is going on?
If we want to understand, we need models because we are human. But nature does not work in wrong structures. So early on, when I was just doing the second degree, I understood that if I want to understand natural processes, I must work on their structure. And at that time, even DNA was not known. There were 3 structures of biological material and quite a lot of organic materials, of normal chemistry.
So one small thing that comes out of that, I have a daughter who's 11 years old, and I'm trying to explore how one can inspire her to look at basic sciences as options. So what have you experienced from your travels and your mixing with people? Are the ways, see, you made it very accessible to us, right?
Well, I go from school to school if I can, in Israel, but also in other countries. In Delhi, I had to have a meeting with kids, but this was somehow cancelled, not by me. And I try to talk to them, and I tell you, they understand. And they have questions. I study from them quite a lot. And many of them, at least from echoes that I get, think about doing science and chemistry in particular now, because I'm so popular. But, no, I'm joking, but it looks like a joke, but this is what happens.
Damle, I represent University of Illinois here. I have a question based on this thing that in business or in human life, its structure, conduct and performance is what the industries are analyzed on a model. How that can relate to the academics and educational institutions in India, if you have any view on that.
Very little. I'm sorry, but very little. I know very little about India,
Okay.
Indian schooling system. I try to absorb what I could in this week, but I think for over 1 billion people country to absorb in 1 week all about school system is a mission that I couldn't fulfill. Sorry.
Yeah, but if the same question can be rephrased, could you tell us something about how this is fostered in your country, right from school to university level?
When I was a student, when I was a pupil in Israel, in schools, teachers were very highly respected and knowledge was very highly respected. Now that, although it's still highly respected compared to many other countries, it's not as it was before because of several reasons. First, the image of teachers is much lower. And second, because the kids think they know everything and they can read everything. And sometimes they are right. And teachers are too stiff to get it. So I'm sorry that I don't have a real good answer, but I could explain that. When people ask me who was my model, I had no model. But who inspired me, these were my parents, my teachers, and the books that I read. So teachers were very important. That was in shaping me, and I think in shaping many people in my age group. Perhaps until 20, 30 years ago when the attitudes changed or became different. My mother would never go to fight with a teacher. I don't think that I ever even asked her, or okay, maybe I didn't need it, but when I was a mother, and my daughter still was in a very good school and still had very good teachers, but they had an attitude that I didn't approve. So they had, in mathematics, for instance, they studied a new topic, dividing, multiplying, whatever, fractions, whatever it was, and they had several examples in class and several examples for doing at home. And they had different views of the same problem, and then about 50 or 60 different exercises, each of them the same one, but different numbers or slightly different looking at it. And she did the first group, and then she felt that she knows, and I asked her, and I felt that she knows too, and then she said, now I have another 50. It means it blocked her time for a long, her available time, took a lot of it, instead of building knowledge, new knowledge, curiosity, looking at new things she had to do again and again and again. So she was already 15. So I went to school, in a school meeting, and I asked, why is it so? They said, how do you suggest? And I said that children at this age can be responsible for themselves. And one that feels, that knows, after 5 or 6 or 10 exercises, why should he do the other 50? Can do something else constructive. You can give them options. Instead of repeating 50 times, go and read about Darwin or about whatever, history, philosophy, whatever you want. And they said, so how will they know? Examine them, make an examination, and then they will also have a feedback if what they think I understand is correct. I think in this age they can be responsible for this. So they looked at me as I'm completely crazy, and nobody took my suggestion. But I think this is one way that things can change. One tells, not you, but the teacher, gave something new and asked to answer some questions about it, and if the student decides that he understands, he can go on and read another book or another page or another paragraph, and then being examined. So this is not done, should be done.
Girard, ex-IIT Bombay and working with Reliance Industries. My question is, the East generally blames West for being too logical. The West blames the East for being too dreamy or coming up with things, you know. So it's said that people work sometimes more with the left brain, logical, and the right brain, say, intuitive. While I was living in Israel for 2 years, I felt that the Israelis are a good combination of both. And also geographically, Israel is in the middle of, West and East. And I think also the research and innovation at a high level definitely requires a combination of both. So what would be your take and advice to people in the East or anywhere as to how should one handle this, apparent but not apparent difference of approach, and how to combine it to bring out the best results?
So what's more interesting?
Yeah, but
now the question is, what are the implications?
Yeah, and what is really happening, and how both can understand each other and come out with a better solution, and how one should apply this in research and innovation.
If we talk about research and innovation, we can talk about this, but about changing the world, I'm not sure I want it. I love the world having differences. It will be really boring if everybody will be like the Americans. No, I'm not joking. I think that in the West, although you told everybody is logical, not everybody is logical. Not at all. Many are functioning according to beliefs, some of them completely unexplained. They are good for the people that believe. I have nothing against this, but I can't explain it. And also a lot of Eastern philosophy and way of behavior is taking part now in the Western world. People are not always very happy with the only logical or only money making or only innovation. there are, even if you look at the academy, which is the most, the highest rank, there are now, in many universities, there are now studies of the East way of thinking, of philosophy of the East, without saying names, but of many of the ways of the attitudes to thinking in the East. The people that's standing behind you on the wall, they're also not very logical, but they are very strong in their belief.
Excuse me, if there's anybody from the media who has questions, then you'll have to ask them now itself.
We'll have a separate thing with the media. Let's have.
Dr. Seema Mishra Thakur, and I had been teaching at the Institute of Science. I'm a teacher of biochemistry for past 26 years. We are really privileged to interact with you this morning. Let me thank you for mentioning one of our scientists' work, that is Professor Ramchandran's plot that most of our biochemistry students in the present few generations had forgotten, and now we are back to it because of computational biology requirements. My question to you is that I'm sure Madam Consul General will also be able to put in some inputs. Our students, particularly we have a good workforce in the field of life sciences. Many students graduate from the various Indian universities. Somehow we have not had much of postdoctoral interactions with Israel. And most students prefer to go to earlier to the US, UK and Australian now universities. How do we go about encouraging our students? Because I too did my doctoral dissertation on marine algae, that I think the species Dunalila, which is existing in the Dead Sea, the only algae to be existing. So just wanted to know how could we encourage, because Israel, particularly Weizmann Institute, is one of the most I would say advanced research institutes, and we want our life science students to have an opportunity to work there. Thank you, ma'am.
So in this room there is an ex-postdoc that was working in Israel at the Weizmann. He's standing there. You want to tell how you made it? You went into it?
Yeah, I did my postdoc 13 years ago.
Dr. Madhu, no?
Professor
from
Madhu,
TIFR. I mean, just to answer your question, I don't want to take too much time from Ada, actually. There are ventures now which are sort of promoting the ties between the various education institutions in India and the same in Israel. It's primarily taken the initiative from TIFR. We did have quite a bit of interaction meetings with Weizmann Institute of Science. It has spread to the other institutions in India and also in Israel. And we hope that more and more such meetings take place and the student flow will increase in the coming years. And I understand that the chemistry department in the Weizmann is coming here for interviewing certain students in May, June, so that they can be drafted into the PhD program in the Weizmann. And this will, I was also told that this will shift to the other institutions in due course of time. So there is something happening in that front.
I also heard that there is an initiative to make Israel-India foundation for research, not only for innovation, which usually means fellowships for postdocs. This is the meaning behind it, because big research or very, very much money is never in these binational things.
I'm a physician with special interest in molecular biology. Your talk was an intellectual feast. I want to ask your opinion on another aspect. Ribosome is the machine for making protein. In the cell, another machine of degrading proteins. Alzheimer's is a good example. At the age of 83, I'm very much concerned about neurodegenerative disorder. Certain proteins must be broken down properly. Not breaking them down leads to accumulation. So neurodegenerative like Parkinson's, Alzheimer's. And I have got a feeling that many ancient Ayurvedic drugs can prevent this kind of a degradation. Any thoughts on that? Proteasome, ubiquitation, another area in which you can guide us about very basic research.
So in our department, in the Weizmann, there is a very active group on Alzheimer, actually on acetylcholinesterase, that's the enzyme. And they looked for what you suggest, natural products that may help. And the first one they found was a plant in Hong Kong. And then they found one in China. And they have lots of contacts with Hong Kong and in mainland China, but neither of these drugs was found to be useful. Although they understand the way it could have been, but it somehow, not everything that we find in the lab or in the test tube or even in the stores can really function in the human body. So they're going on, I'm sure.
Now a transgenic mouse model of Alzheimer's is available. At birth, these animals are quite normal, and within 3 months' time, they develop all the changes of human Alzheimer's disease. Now, I have got a DBT-supported project that Ayurveda describes 10 Medhya Rasayans. The list is here. They are claiming to be Medhya Rasayans. So my plan is to buy 40 transgenic mice, study them from birth with optical imaging and PET imaging, and see the preventive effect of ashwagandha and all the Medhya Rasayans. Today there is no treatment for Alzheimer's. So in 1 year's time, if my mouse model experiment succeeds, we can show to the world that Alzheimer's can be prevented by these Medhya Rasayans, and we'll have a world market of $15 billion. 5 years back, I could not get those mice. Now they are commercially available. And at Attract, there is a mouse imaging. I don't have to kill the mice. So will Israel be of any interest? One Korean company has shown interest. That just as you study those Madhya Rasayans in Mumbai, the Koreans can study them in things. So that the sample increase. Each mouse costs $300. So I'm buying 40 mice, insuring them for 1 year, so that from birth to 1 year, at Attract there is a facility. So any ideas or any suggestions are most welcome. But the world market of Alzheimer's is $15 billion, and India has a good chance, and hope that my 1 year's experiment succeeds. Any thoughts on this?
Well, go ahead, and I wish you all the best. You already have the experiment in your head, and I'm sure that if you have 40 mice, you say, some of them will give you some surprises, and maybe the surprises will be the important things.
I won't kill the mice. So
No, by no means. You pay so much, you want them alive. But even if they are alive, maybe they will surprise you.
In Israel, any interest in transgenic mice?
Yes, there is a lot.
I would like to interact with them.
Okay, so I don't remember the names in my head, and I'll be very bad with it. But if you Google Israel and transgenic mice, you will get a very long list.
I have one question. I'm a research fellow with the Observer Research Foundation. It's about your presentation. This part I didn't follow. If you could just clarify. You spoke about how structures crystallize, salt crystallizes, sugar crystallizes, and then people tried to crystallize ribosomes, and they were unable to do so, and there were some 20-odd papers published on that. And why were they in the first place trying to, crystallize ribosomes is something I didn't follow, if you could.
They wanted to understand how ribosomes work. They had all wish to understand. When the DNA was discovered, and it was on one of my slides, then I said that the ribosome is an RNA machine. Francis Crick, there was Crick and Watson that were based their research on Rosalind observations. He said that must be that there is an RNA machine to make proteins according to the DNA. So they looked for a connection. And Messelson found the messenger RNA. He just found that it exists. And now it became clearer. There is a code and there is something to transfer message. So who will do the work? There was a scientist in Romania called Palade that ran away from the Nazis to America. And there he discovered what he called RNA-rich particles in cells. I think that he did it. There is a dispute if it was in New York, in Rockefeller, or in Yale. But he was in both places and he found it looking at cells. Now there were known particles that the messenger came to them and protein came out. So how is it done? And there was a scientist, Nomura, Japanese in America, in medicine, that found that this RNA-rich particles are not just, I don't know, pudding of them. They are particles that have structure, that they have composition. He actually talked about composition. He isolated them, he took them apart, he showed that there are 80 components in human, 50 components in bacteria, put them together and got proteins out of them. So they were functional even after he opened them and closed them. So now people wanted to know how it's done, exactly like me. They had the same motivation. Now, they didn't take into account the deterioration. They didn't think about it, and I'm surprised because in all the laboratories in the world where people worked on ribosomes, and there were about 200 groups or so, always they knew that when they extract ribosomes from cells, they expect so much activity according to the amount that they extracted. They measured the amount, and if they got half, they called it very active. So what happened to the other half? And what will happen to the half that they got within hours or days? So they didn't think about a system that is constantly deteriorating. They didn't think that they have to keep it together. This was the great thing that the bears understood. Or maybe not the bears, but nature understood. And provided it to the bears, and I took advantage of it. But the motivation was the same.
A Nobel scientist. But I think the more important question is how do you attract young people to do research, more young people to do research? Because I think we realize that there aren't enough people going into scientific research.
Yeah, I agree, and this is why I talk to young people about the Nobel. It's really not a motivation. Should not be a motivation. People call it lottery. I call it accident. It happened to me, so I enjoy it. But my real joy was when I saw the structures and I started to understand. And if you look at the number of scientists, even you say that there are not enough, it's still hundreds of thousands around the world, and 3 of them may get, if they work on a project that fits what the Nobel Committee thinks, may get once a prize. It really should not be a motivation. I think the motivation should be curiosity. And I think teachers, and I tried to say it earlier in an indirect answer, that teachers should encourage it, and maybe you can talk to your teachers. I'm trying very hard in Israel. And I'm trying also in the world, whoever wants to listen to me. In Israel, there is people told me, I didn't see it myself, but people told me that the television channel 1, it's one of the channels of the television media, did a poll in Tel Aviv about how many young people want to go to science in the middle of 2009, with no correlation to any Nobel Prize, just on the street. And they asked, and the number was extremely low, a few percent. And even those, they were not, the word chemistry was hardly mentioned. And then after the prize, the day after the ceremony, they went again to the same street and met again with young people. It was half a year later, not a long time. And they said that the numbers went up by over 40%. So the numbers are still not very high, but went up a lot. Now, I'm not sure that all those that say in the street that they are going to be scientists will, but at least there is a motion towards it. And now in all the schools in Israel, in all, I think, 6 or 7 graders, they are asked to find figures that people that changed their life or inspired them or made a big influence in Israel. And I'm one of the victims. And a lot of children write to me, and a lot of classes take it as a class. So there is a possibility to make some impression, but it's not enough. And the most important thing is that whenever they ask me how to get the Nobel Prize, I said, if this is what you think about, don't go to science. You will be miserable all your life. You have to think about understanding. How to do it, I don't have a recipe. I can just try to convince.
Connecting with the question, Manjula's question.
Please identify yourself.
Jaya Abraham, and I work with Wellspun Energy. So we have large interest in getting into the academic institutional bit. The people seated here are just a microscopic of the population of this country. Okay, as she spoke, there's a large number of students who nobody would get to know, but who are brilliant. You know, we have a story in Bihar, in one of our states in India, where a man picks up 30 children every year and he trains them for IIT, and he's got 100% hit rate in science to go to like where the professor is from. Okay, I want to ask you, you being from simple beginnings, professor, in your day and time, what is it that your parents and your teachers inculcated in you or inspired you to think beyond your means that time, 50 years ago, that has brought you so far, which we can take back as Observer Research Foundation in being able to include the larger percentage of our 540 million youth who are educated and unemployed?
So I'm sorry I cannot tell you that my parents stimulated me to do science. They were like these guys there on the wall. And they not so bad. They became pioneers, but their education was strictly religious. But when they saw that I want to learn, it's okay. And when they realized that if I go to a strictly religious school, I won't make it, they let me go to others. It was very difficult. They were very poor. We were a very poor family. My father was most of the time under surgeries. He was ill, and he died when I was young. Still, they never disturbed me. My teachers were very good, and I think my parents, although they were not scientists, they inspired me in the fact that they supported everything that I found for myself, good for myself. And that I think the most important thing, this and the teachers. So there was never a consulium in my home that say, Ada, you have to study or something like this. No, never.
One last question, please.
I can't hear you.
Dr. Yonath, my name is Utpala Adhik, and I'm actually the founder and editor of a public relations website. I launched it 7 years back. It's a research-based website, and in fact, my website is very broad-based. I've been doing a lot of research. The articles that go up on the site, of general interest. It's to do with a lot of topics. Because it's a media website. Dr. Yonath, my question to you is something like your topic, which is very, very specialized. How do I get the common people to sort of, get an interest in something which is so specialized? Because that's the reason, I didn't get into very specialized kind of research articles on my website, because I thought, it's sometimes difficult for the common person to understand. So I've stuck to, areas of, which is of general interest.
I cannot give you an advice, I'm sorry. Maybe if you want them to look at it, put some other things that may attract. There is now running in the internet, in YouTube, a video about a retreat about people from a laboratory in Texas that went to a retreat and made a show there, how life is in the lab. It's really, really funny. Maybe ask their permission to put it there. Zeng Lab, it's called Zeng Lab. In Baylor Medical School in Texas, in Houston. Something like this maybe, but even this, I don't know how can you advertise it.
Thank you very much, Professor Yonath. On behalf of the Observer Research Foundation and on behalf of all the people who have come here for today's roundtable, we extend a very, very heartfelt thanks to you, and thanks also to Orna. We are very happy with this collaboration, and now that we have entered the 20th year of full diplomatic relations between India and Israel, we look forward to more collaborative efforts ahead. We would like to put flesh and blood into this concept of India-Israel Innovation Initiative, and we request all of you friends We had very, in a very short time, stimulating discussion, very good ideas came in your questions and comments. We would like you to also contribute to this idea of India-Israel Innovation Initiative, how to foster innovation and also research in our academic institutions. We would be shortly writing to all of you. Thank you very much. Our friend, I must also thank Professor Madhu from TIFR for making this happen. He's in a hurry to take Professor Yonath to TIFR for another function there. Thank you very much.